Okay. Hello, Miriam. All right. Hi. Thank you. You're very kind, Kirsten. Hi, Sumaya. You're very kind and observant. Happy Halloween. Yes. What would make you say that? Okay. Yes. It's spooky. Yes. Well, physics. It's spooky. Okay. And so happy Halloween to Sarah. Happy Halloween to Jada. Spooky to Kay. Welcome back, Kay. Or good to see you, Kay. Good afternoon, Montserrat. Hello, Jose. Hello, Brian. Did I say hello? Happy Halloween, Miriam? Oh, wait, did Miriam? Oh, yes. Happy Halloween, Miriam. Hello. Thank you, Gianna. Happy Halloween, Brianna. Top of the, paranormal. Nice. Del, okay. Good afternoon and happy Halloween to you, Stephen. Awesome. Awesome. Okay. I'm looking at the, okay. Awesome. Okay. Yes, if there's any, and I promise I'm just doing this for the children. Okay. No, great to see you all. And in fact, more people here. Okay. Okay. The funniest thing is, wait, someone's here, but I can't let them in. Hold on. I know. Why can I not let them in? Okay. If I can't, wouldn't it be cool if you could, Mr. What are you? Yeah, I don't know. I have no idea what wait, Mr. What are you? Want to say which? Yeah. I'm just like a generic warlock wizard. I mean, right. I don't know. I'm having an identity crisis. I mean, once upon a time I wanted to be Dumbledore, but it just all fell apart. And now I'm just, Wizard 101. Right. I'll take it. Thank you. You know what I wish? The funny thing is these people like waiting in the waiting room that I can't let in. I wish I could just like leave candy emojis in the waiting room. Like how cool would that be? But okay. Or then they show up and they get a trick because they wanted a treat, but they get physics instead. Ha ha ha. Okay. No, it is good to see you. Yes, I'm trying too hard. I'm the little brother that wanted attention. I'm the okay. Wait, what is that? Oh, is that a candy emoji? Wait, what did you just do? Oh, that's awesome. How did you? Oh, that's very cool. Oh, I got to figure out how to do. I think I know how you did. I don't know how you did that. That's awesome. Maybe that's really awesome. Okay, but anyway, yes, the only thing that's more spooky and creepy than a physics professor is a physics professor who tries to dress up. They're all doing it. Oh, that's totally cool. Oh, I should totally open up a portal for that. Oh, I guess it's okay. I think I know how you did. Oh, click the smiley. Oh, right. Okay, cool. Yes, good. All right, I might do that when we. Okay, cool. Now here's the weird thing. All right. Well, speaking of tricks or treats, so the treat is the costume. The trick, it's not a trick, but I'm not the costume is meant, or the holiday is meant to soften the blow. Now the flip side of the equation is, so we do have this exam coming up, right? We do have this exam. I don't want to over talk it. My goal is to reduce, not increase it. Wait, someone else just came here. Okay. My goal is to, but there's always going to be some stress associated with exams. Believe me, I don't want any more than is just naturally part of the process. We try to make the exam as unstressful as it can be, but it always is some. So hopefully, what's my point? My point is hopefully you just got in your Google Classroom. Hopefully this morning you got or a couple hours ago, you got a document that's just called expectations re-exam. Like there's nothing to do with that document. It's just to make things clear. In fact, maybe I should do one of these things where just to confirm that you got it and understanding, maybe I should give points, but I just want to be as clear as possible. This is how it works, that this, let me work backwards. So just, okay, sorry. You see, exams stress me out. I hate exams. I don't know if they stress me out as a student. They stress me out as a professor. I don't want to, and if you're not stressed, don't let me stress you. I mean, that's good if you're not. But if you hear any stress in my voice or any anxiety, please just take that as sympathy and empathy and don't let it make it worse for you. So let's just be clear. First of all, can you just like raise an electronic hand or say something just say yes in the chat if you got the document that says that says exam expectations too. Okay, thank you. Good. Wait, I'm just switching the view. Awesome. Thank you, Abdel. Thank you, Sarah. Thank you, Montserrat. Thank you, Jose. Thank you, Stephen. Thank you, Alsmael. Okay. And the other people, just please look for it. I mean, I'm going to assume from those 8 people, and thank you, Brian. Thank you, Gianna. Thank you. Okay. So I'm going to assume from them that it did land. So those of you who look for it, it's under material. It came out a couple of hours ago. It's not anything for you to do. It's just to make the instructions clear. I'm going to say them again here because I don't want there to be any surprises. That a week from this Thursday, and Sarah, are you, thank you for acknowledging. Are you also asking a question or are you, okay. Thank you all, seriously. Okay, so just to be clear again, next Thursday, it gets posted by 8:00 p.m. Might be a little bit earlier, but it'll get posted by 8 p.m. a week from this Thursday, November 10th. And then it'll be due before class on Monday, the following Monday the 14th. It's due before 3:05 p.m. You've got to turn it in before 3:05 p.m. and then you've got to show up to class. Like that's your last responsibility to the exams, to show up to class. Largely because otherwise it looks to your colleagues like you're still working on the exam, and it's totally unfair to them if they finish the exam on time and get it in and then they show up to class. But so even if that's not why you're not in class, if it looks that way to them, it looks like you're getting an unfair privilege, and then they're like, why did I follow the rules, blah, blah, blah. And so you got to hand in the exam before 3:05. You got to show up for class at 3:05. You've got to understand that I'm still super casual and about homework deadlines in both directions, yours and mine. You can still be handing in homework even past the exam. That's all fine, but the exam is an exam and does have to be turned in on time. Last thing on that, we'll talk about it more as we get closer, but that doesn't mean that exceptions can't happen in the universe, health crises, family crises. But you've got to communicate if something is going on in the middle of the weekend where you know the exam's not going to come in on time, you've got to communicate with me by text or email, and we'll make an arrangement. You just can't just hand in the exam at 3:10 without any prior explanation or prior arrangement and think that that's okay. That wouldn't be okay. Okay. So the exam will be posted Thursday, November 10th, before 8 p.m. Prior to 8 p.m. this coming Thursday, a practice exam will be posted, just to make it a practice exam that will be incredibly similar to the actual exam, incredibly similar. So similar, like that's the thing you should study. That's the thing you should prepare, is the practice exam. It hasn't been posted yet. It will be posted by 8 p.m. this Thursday. Someone's here. Hold on, sorry. It'll be posted by 8 p.m. this Thursday. Then what you do is you take it home and you try to work on it as though it's the actual exam. You work on it with friends, you work on it without friends, you work on it with the internet, with that. Like my advice, my advice is you try to do it without looking first and see what you can do without looking. And then everything that you have to look, or everything you don't understand or you don't remember, or then you look and you talk to friends and all of that. And you do a full run through of the practice exam using whatever sort, or something you realize, oh my God, I never learned this. I never understood this. Then you work backwards and you learn what you need to learn for the exam, and you do work backwards. Like don't sit down with a book and try to learn things about this course, like out of nowhere. Find out what you need to learn from the practice exam. That's its purpose. Blah, blah, blah. And then you come in Monday and Wednesday of next week with questions about it. And that's how we review for the exam, is I answer questions about the practice exam, somewhat Monday, but primarily Wednesday. I won't devote the full period both times to that, but I'll devote a lot of time to that. Also, last thing, just to be as clear as possible, and then I want to move on for now. Yeah, wait, good. Hold on. I'm just looking, there's something in the direct chat that I'm sure is relevant. Oh, this is a very good question in the direct chat. And right now, there's only one question in the direct chat. So if you put something in direct chat, then it's you, and good question. I'm glad. So someone's put in the direct chat, and I'm glad they wrote, they wrote, I just want to be clear. Is the actual exam due on the 14th? We only have to attend class to prove we finished with the exam, and not because we are taking the exam during the class, correct? That is a very good clarification. And the answer is yes, correct. But let me slow down and reiterate that to everybody, because I do want this to be clear, and it is unusual. So, but also makes me, yes, that is what I'm saying, direct chat person. Thank you for clarifying. I'm saying to everybody that your actual midterm exam will be posted no later than 8 p.m. on Thursday, the 10th. Then you have that full weekend, kind of a 3-day weekend to work on it. Then it must be submitted. So it's a take home, untimed, open universe exam, but then you finish it and you submit it via Google Classroom no later than 3:05 p.m. on Monday, the 14th. So it's over. That's right. The taking of the exam, the stressful part, is over as of 3:05 p.m. Monday, but then you show up to class. That is what I'm saying. Like, it's an unusual arrangement, but basically part of it, the point is we need the class time. Like, we're not taking the exam during class time because we're using the class time to do instructional stuff that we need, like for the sake of the final exam, et cetera. So that's part of it. And part of the deal is, like, if you get this big bonus of getting to take the whole, not this big bonus, but if you get this privilege or whatever of being able to take the whole thing untimed for 3 days at home, then yes, I'm saying part of your obligation is then you show up to class nonetheless. But to answer the direct chat person's question, right, once you show up to class at 3:05, which you do need to do, then we're doing other stuff. Like, right, you're done with the exam at that point. Now you breathe. And look, I'm not even saying class is going to be hard, but I'm saying that you show up to basically show your colleagues and your classmates that you're done, and they're showing you that they're done. And then we'll breathe out. Like, I'm not saying I'm then going to pound you with like super hard. You'll all be exhausted, like, hopefully, or you'll be drained, but you're just going to show up to be like, whoo, right? Or to complain to me and be angry at me or whatever. But yes, you know, she or he has got it in direct chat that you hand in the exam and then you show up. Because again, like what we all know, what everybody would do if otherwise is that you would just keep working on, like, a lot of people won't even realize that the exam, they just won't get to it till too late. And then they'll be scrambling during the class period to still finish it. And what I'm saying right now, especially because I'm a loose guy, and I seem really forgiving about a lot of things, and I am about a lot of things. But then it's easy to misunderstand if they go, okay, whatever, he's not going to care. I'll just like, I'll get it to stay. I'm going to keep, now that I got momentum, I'm going to keep working on this thing till 4, and then I'm going to hand it in. Like, no, what I'm saying is no, you can't do that. And part of the reason you can't do that is because I'm saying you can't do that. And then if you do that, then your other colleagues who did show up to class are like, what's up? And then they assume that I'm just giving you a break, and they kick themselves for being so stupid as to have followed the rules. But I'm saying no, like, and literally I am saying anybody who just doesn't turn in the exam on. So basically you should all know that anybody who does not turn in the exam on time and or does not show up for that class and hasn't, if you don't see them in class that day, you should know they've either made a prior arrangement with me, which you could make too if you have to, or if you don't have, like, because something happens, or if you don't have to this time, then it'll be your turn during the final exam or during some exam in 204. Like, individual circumstances come up for people at various times, and you could be one of those people. So if you don't see somebody in the class on Monday, on Monday the 14th, when this thing is due, you've got to believe that either they made a prior arrangement with me because of some personal circumstance that they had, and it's not because they're special, it's because they communicated with me, and you could do that too if you ever needed to. It's like a card you can play, and if you play it every time, then obviously nobody trusts anybody, and then there's an issue and blah, blah, blah. Like, and then that's bad and it doesn't work. But if one time out of 4 exams in 203 and 204, one time something happens in your family or something, and you can't even get into the details with me, but you just like show me the foresight on Friday, be like, Yaverbaum, something bad is going down in Queens, and like, I'm responsible, and I'm taking a test to become a cop, and I have to arrest 14 people, and I'm in the but I can't even get into the details of why I'm in a hospital because it's personal and it involves my spouse or something. Like, you could say, can you cut me a break, and I will like turn in the exam 2 days late, and I won't like, yeah, something like that could happen. And it could be you, or it could be your friend. And as long as you communicate it to me and we make the arrangement and I say, okay, I trust you, it's understood, like, let's not have this happen every single time, then cool. So Monday, when you look around and you've killed yourself over this exam and you've turned it in and now you've shown up to class, even though you hate me and physics is the last place you want to be after you've sweated this exam. If you look around, whoever is not in that Zoom room, I'm telling you right now, either made a prior arrangement with me that someday you'll might have to make also, or they didn't. And I promise they're losing tons of points on this exam. Like, I promise, if someone just knew, not the one time that I ever actually get my feathers really ruffled is if anybody just literally no call, no shows on an exam, like just literally just turn something in late because they just assume I'm a pushover and they didn't communicate it in advance, or they didn't show up to class today because they just assume it's not a big deal. Oh, believe me, they're going to lose a lot of points on the exam and they're going to get a lot less compassion when it comes to the final exam and other, like, that's an offensive thing to do to colleagues and to me. And I don't mean to be on this offensive note right now, but just because that was such a good question, anybody who's listening to me right now, as usual, has a huge advantage, because I'm telling you right now, like, this exam, like, everybody can still get an A in this class, even if you haven't studied once yet. Like, I'm setting it up so that as long as you actually like follow all the instructions and hear me and take that practice exam super seriously and actually work with your friends, because it actually is a really worthwhile thing to do. And it's actually secretly what I'm trying to encourage with all of these systems. If you guys actually work on the practice exam together in your free time, or in a like in a Discord server or something that you set up, like, you'll be in a really good position to do well, even if you've been confused or spacing to this point. But I am going to tell you right now that there will be 2 or 3 people that will fail the exam, and there will be a couple of people who will violate the rules that I just said, and who will actually have severe numerical consequences as a result. And the reason I can say that with confidence right now and not offend any of you is that those people are not listening right now. Like, okay, like, literally, this is one of those things of just like the reward for just hanging with class and staying with class and participating in class is that in class, you're being tested on how much you're in this class. And the more you actually get the vibe and the culture of this class, the more nothing will surprise or throw you or trick you, even when it comes to hard exams. If you just know how to play by the rules that we're setting down that are somewhat unusual sometimes, you'll be fine. And they all work and they all are good, because there will always be just enough people who won't do fine because they're not even listening right now. I mean, not to, and you know, or in general, they're not. And the other reason I say things over and over again, and why I post it in the Google Classroom and I'm putting it here and putting it there and putting it on videos, is that anybody who wants to know what's going on can find out. But there's always going to be a couple of people who just think that they can just get this physics material from Chegg or whatever else, because they just think it's just like physics in the standard way or whatever. And they'll just try to do that at the last minute, and they will have missed all of this, all of these nuances. And those are the people that are going to save the curve for the rest of you, to be blunt. Okay. All right. Sorry. I didn't mean to get okay. But wait, I'm going to ask this. First of all, when he or she gets a moment, can the direct chat person who asked that question, or I think today, wait, there's okay, wait, there are other, the person who asked me that question, can they just tell me if I answered it clearly? But now, wait, when they get a chance. But now there's someone else in the direct chat, okay, with 2 questions in the direct chat from the same person. So, okay, I'm going to answer these because I want this all to be clear, but I don't want to take up too much but all right, no, these are good questions. I'm going to answer them in the opposite order. And you should keep these questions coming. Anything that's unclear about this exam, I want to make clear. So one question someone's asking in the direct chat is, where is the practice exam? It's not posted yet. It will be posted. It says in the thing, it will be posted by 8 p.m. this Thursday. So you'll have this weekend to do the practice exam. So it's like literally practice. It's like practicing the experience of what next weekend will be like. So it will be posted by 8 p.m. this Thursday, and you take it over the weekend and you don't turn it into me. It's literally practice. Okay, and you do work it out with your friends, and then you try to do it, and then you come in and ask questions on Monday and Wednesday of next week. So I'm hoping I'm answering this. So let me say that again, because someone, at least in the direct chat, is asking, where's the practice exam? I'm saying it's not posted yet. It'll be posted this Thursday by 8, like November 3rd by 8. Okay, okay, cool. Thank you. Oh, okay, cool. Thank you both. Okay. Then there's still yet another question I have to answer in the direct chat, but good. Thank you both for, okay. So there's another question in direct chat, but before I even get to that, I also want to say about the practice exam that will be posted. And any of these questions too, hopefully I'm answering now, and we'll make sure that I'm answering now, but I try to answer them in that memo that just, the thing that's the document that you just got this morning, expectations of practice of exam. It's a lot to read. I know it's like boring, just like this video or this class is boring right now, but like it's information you'll like, just remember, it's like anything else in the exam. You're going to really want to know it once you're like sitting down to deal with this. So it's all there when you want to refer back to it. It's more than you can deal with right now, but that's where you want to look if you're confused about any nuances about this exam, because it is an unusual system, perhaps. The document in materials under exams that just came out that says expectations, that will hopefully answer most of your questions. Two more questions to answer about it though. Two more questions to answer. Well, the one that's in the chat, same person's asking, what do I mean by open universe exam? Oh, good question. Because yes, I'm using that I mean, it's sort of a silly term, but I do mean it seriously. Every time I'm saying this exam, the real exam is open universe, meaning open book, meaning open everything. Open book, open notes, open textbook, open internet, open friends. Like, see, I'm not joking about that. And if you're hearing me correctly, you probably should either think that I'm joking or that I'm crazy or that I'm a naive idiot. Like, if you're having any of those reactions, then you are hearing me correctly. Because yes, I'm saying, but I'm not any of those things, in my opinion. Let me say this again. When you get the actual exam on Thursday, when it gets posted, Thursday by 8 p.m. on Thursday, November 10th, then you're going to have all weekend to do it in fully untimed, fully unmonitored, fully open conditions. And you're going to return it by class time, 3:05 p.m. The following Monday. Let me expand. And I'm saying open universe. Yeah, like I'm saying open everything, open book, open your dog. Who knows physics, supposedly, whatever. Open book, open textbook, open Khan Academy, open whatever you want, open whatever. So as long as I'm saying that, let me make more clear what that really means or why or what. What I'm saying is when the exam gets posted on Thursday, November 10th, it's going to be posted in Google Classroom just as though it were just like a big homework assignment. Only it'll be called an exam, not a homework assignment, and it's worth 100 points, not 20 or something like that. And it'll look kind of like 3 or 4 homework problems, like long problems with the fact pattern at the top, and then a bunch of part A, part B, part C. It'll look like 3 or 4 homework problems like put together in a packet. And what you're going to do is just like with the homeworks, you're going to take out separate blank pieces of paper and you're going to write out full solutions on the separate blank pieces of paper. You're going to treat separate blank white sheets of paper as though they were a blue book. You're going to write out full, like 5-step method solutions to each one of the problems. You're going to label them like fully clearly. You're not going to copy and paste my problems into your white sheets of paper. But you're going, just like in homework, to make each question fully clear what the question is. You're going to make it so clear that you're going to make it really clear. Then you're going to take all these pages that you did all of this physics work nicely on white paper, like maybe with many different colors or many different handwritings or diagrams here and there. Like you're going to make a nice document, a nice presentation of your full solutions to these problems. Then you're going to have it's going to be a multi-page document. You're going to scan it in just like you do with homework. And this is why all the homework has just been practiced for this moment. Then you're going to scan them or photograph them, whatever, and you're going to have, and then turn it into a PDF or a Google Doc or a Word doc. And if you don't know how to do this by this point, then you need to ask me and I'll show you. You're going to now have one document that's consisting of multi-pages, and you're going to submit that in the portal, just exactly the way you do with homework. That's why we've been doing things that way. But it's just that this is big and counts more, and we're more rigid about you getting it to me at a certain time and me getting it back to you at a certain time. It's like the real deal, but it's just that same formatting where you do it out on separate pieces of paper, you scan them, you turn it in like online, you know, and you could turn it in early if you want, but you turn it in no later than 3:05 p.m. on Monday. I suggest that you do drafts and rough copies first, because the final thing you're going to turn in is a final copy. But even if you can't follow my suggestion, that's what the practice exam is for, to sort of force you to do drafts before you do the final thing and see what's what. Some of you do actually type your homework, and some of you feel comfortable doing math and physics like straight into the computer. If you're comfortable doing that and you can do the diagrams and everything that way, Cork, bless America, go for it. But that's not required though. Most of you will write this out because it's like math science type of problem solving. Most of you will write it out and then scan it, and that's totally cool. But your final thing that you're turning in has to be as neat and clear and comprehensive as possible. You should have all the steps of your reasoning. You are there in your final copy, not just to show me the answers, because I already know the answers, and I know that you have the answers all over the web and all of your friends' notebooks and all of that. You're there to show me that you understand why the answers are the answers. Your exam is a proof. It's a proof not only of the physics answers, but it's a proof that you authentically understand the material by the time you write it down. Your goal is to get the information and the understanding any way you want. Khan Academy, friends, your notes, having attended class would be the best way and the most efficient way. But then by the time you get the information, you're writing down things that you, only things that you understand, that you could defend to me in an oral exam if that were to happen on Zoom or in my office, which it does for some people when I doubt the authenticity of their work. You should be prepared to defend anything you say in your exam to me vocally if I ask for that conversation. Last thing, okay, so sorry, not to, I'm getting firmer and firmer. I don't mean to be sounding so like, but right. I forget. So that's what you turn in. Oh, so open universe means that you could do whatever you want to do this exam, but by the time, and you don't have to give credit to your friends for having helped you with something. You can get, I want you to get as much help as you can, but help understanding it, so that by the time what you write down, it's by the time you write down your final draft, what you're writing down is what you personally understand. And that's what you're showing to me by including every step of your reasoning and by as many sketches and different colors and neat diagrams, neat handwriting as possible. You should submit to me a document that I don't have to look at my original test questions in order to grade your document. It should be one, like you don't copy and, just like homework, you don't copy and paste my questions, but your answers make the questions so clear and they're so fully labeled and ordered that I could just go through your document and assess it by itself without cross-referencing anything. Last thing, and then I'm gonna look in the chat again. And luckily, and by the way, I hate to beat these, I'm talking about all this, I can hear it in my own voice. I sound stressful talking about this, or I sound stressed. I apologize for that. It's because I do get stressed by these things, but I'm saying all this to try to assure you all that if you actually follow the guidelines and if you accept this somewhat unusual procedure for test taking, it's designed to make your life better. It's designed so that anybody who's actually trying to understand this material by the time it's due is in a position to get a really good grade. What you're trying to do is authentically understand and demonstrate. You're not trying to rush or like fool. It's not about correct answers. It's about understanding. So to that end, what I was going to say, last thing, I'm going to post this practice exam like a week in advance. It'll give you a really clear idea of what the actual exam is like. Like it won't just tell you the topics. It'll strongly resemble. Basically, your practice exam is my draft of your actual exam. It's like, it's a draft of it. So the question you might be asking, or one of the direct chat people might be wondering is, wait, well, do we get answers to that practice exam? So here's the story with that. You don't get them right away. Like first you have to work on the practice exam and work together and see what you know and what you don't know. by the time we have class the next week, and in the 2 classes we have the next week, the way we review and answer questions and stuff is I will start giving you solutions to that practice exam. Some I'll like literally give you as class notes in the class. That's why you'll want to attend class. Some I'll post online. I will actually give you some solutions to that practice exam, which means in effect, I'm giving you solutions in advance to the actual exam, because the actual exam will look very much like that practice. But here's where it will differ or where it won't. Anything that I give you an actual solution to that we either discuss in class and I walk you through, or I post on Google Classroom, anything that I actually give you a full solution to, you can bet that I'll like change the numbers around and change some details just enough to force you to have to think it through and make sure you understand for the actual exam. I won't change the topics. I won't change the basic nature of the questions, but I'll change some details to make sure you're paying attention and you're not just blindly copying. But anything that I don't give you a solution to by the time you get to the actual exam, if by the next Thursday, the 10th, you get the exact actual exam and say problem 3 of the practice, I never gave you a solution for, or we never like really talked about that much, then what you can assume is that that one will appear on the actual one verbatim. Like, meaning the reason I didn't give you a solution is that's literally the way it's going to show up on the actual. So instead of a solution, what you've had is like a week to figure it all out and work with each other and get the answers. And so you could think of that as a research project if you want. So by the end, there's no mystery about having the answers. You'll know pretty much. You'll have plenty of ways to get all the answers to this exam by the time it's due, which is why that's not how the grading goes. The grading is about, did you demonstrate and fully prove that you really understand why the answers are the answers? That's how the graph. So the exam, sorry, I'm taking way too long with this, but it's an unusual process. Oh, and let me say also, this whole process, even I hope you'll like it. Most people, once they get over the surprise, most people that pay attention and have been coming to class, this usually ends up rewarding them. And it punishes people who never come to class. But whether you like it or not, once you get used to this process of taking exams, I can tell you this is exactly the way the final exam will be. It is the way the final exam will be. And it's the way I do exams in Physics 204 as well. So all the talk that we're going through now for all of this is also just to get us around the hump that then this is it. This is the system for the next like 3 exams you take over the next semester and a half, for what it's worth. And again, if you're actually being super honest and really trying to learn and understand, then you can do really well on this. If you're trying to cut corners and just show me answers that you got from Chegg, it's designed to not work for you. Okay, so I think, okay, so wait, let me just look in the chat again. Sorry to be so, okay. So it looks like I answered, okay, so I looked the people in the, okay, so those people in the direct chat, sorry to overtalk it. That's how the exam works. Again, it should be please work together. Please use it. It's also designed to just force you to learn the material by the time it's due, if that makes sense. Like, the exam is not to test to find out whether you have been understanding things the whole time. The exam is to make you get to the point of understanding things by the end. And it works for anybody who just keeps paying attention and keeps coming to class. Okay, that said, so, but still, all right, so wait, I'm going to pause for a second. Do you got, I know it's a little bit unusual, but can you raise your hand if you think you basically get how this exam is going to work? Cool, that was fast. Thank you, Sarah. Thank you, Jose. Thank you, Brianna. Thank you, Gianna. Thank you. Well, that kind of rhymed. Thank you, Jose. Thank you, Montserrat. Thank you, Samaya. Thank you, Stephen. Oh, and thank you. Okay, and 2 others. Okay, and thank you, Katya. Thank you, bro. Okay, so the other people is there anybody who's, you may not let, okay, you can put your hands down. Thank you. Wait, just to be really clear, is there anybody who's right now actually believes they're confused about this process and knows they're confused about this process? Okay, and it's a weird question, but okay. So now we're going to go on with the material. We're going to go back to material. Here's the weird news. Oh, it's not, well, the weird news is you guys are a little bit, last class, I gave you this problem that had to do with adding vectors, adding 2 two-dimensional vectors. I gave you a problem that had to do with adding 2 two-dimensional displacement vectors. And you had a little time to try to solve it. I think you tried to solve it in the breakout rooms. Yes. And then I went over it, actually. Now, that actually put you a little bit ahead of the other class. That's the good news. So I can be a little calm in going over this right now. And we might even get out a little bit early in honor of Halloween, if that helps you. The problem, because unless I'm wrong, I think we went over like this problem, that problem is what we signed last time, and I believe that I went over and gave you a solution. Well, let me start. Okay, right. I mean, I did. I gave you a solution. I have some more things to say about it. I'm not going to start a whole new problem today because I want to keep the two, because you're a little bit ahead. So I'm not going to start a new problem today. I want to make sure that this problem is as clear as it can possibly be. Is this allowable material for the exam? Sure, this is allowable. Like everything that happens until the exam actually happens is allowable. That's why you're not getting the practice. So something like this is on the exam. The whole exam is about kinematics, which means the definition of motion. Most of what we've been doing for the semester has been one-dimensional kinematics. Now we're up to two-dimensional kinematics, which means vectors. The thing that we're doing right now is adding two-dimensional vectors by the component method. That's what we're doing right now, adding two-dimensional vectors by the component method. The method that I showed you on last class was being applied to this problem of displacement vectors. We have two displacement vectors that are being added together in this problem. But just to be clear, if you understand this method, it works for any number of displacement vectors, and it works for any kind of displacement vectors in any number of dimensions. Like we're doing two-dimensional vectors. It could have been three-dimensional displacement vectors. And this method, I think it makes the most sense and is the most straightforwardly predictable when we're talking about displacements, but it will work for any kind of vector quantity, including velocity, acceleration, force, and adding velocity vectors will be on this exam as well. It's like the next and the last thing that we'll do before the exam. When we add velocity vectors together, we'll add them by this exact same method. So if you understand the math here, the math is exactly the same. Only the physical meaning of what you're doing is a little bit less obvious. That's why we do this first. So I just want to tell you in advance that this method, adding vectors by components, will work for the rest of all of physics. It'll work for force vectors, acceleration vectors, any kind of vectors. When you want to add them, you divide them into components first. That's the principle here that we're doing. For the problem that we did last Wednesday, so here was the problem. I'm just going to remind you that I believe, I'm going to scroll through this quickly because again, we did it, but I want to make sure this, sorry. So the problem was that you walk 5 meters at 30 degrees to the northeast. And then so you start over here at point 0, you walk 5 meters, 30 degrees to the northeast, you end up at point 1. Then from point 1, you now walk 8 meters at 60 degrees to the southeast, and you end up at point 2. And we want to know at the end of the day, how far away and in what direction is point 2 from point 0. We want to know the total displacement accumulated when these two individual displacements were added. So these are two displacement vectors that we're adding together to get one big total displacement vector, right? And what we said, if this were a problem on an exam, like to solve this problem, step 1, diagram and fact pattern. Here's a diagram in the yellow box at the top. This diagram that I'm drawing is just that. It's like a step 1 diagram. It's a diagram that represents, that depicts the question. It does not answer the question. It gives a sense of what the answer will look like, but it doesn't compute or solve the problem. It just shows the problem. And what it's showing there, just to remind you or to summarize again, it's showing you something that I hope seems straightforward when it comes to displacements, but then turns out to be true of any vector, any set of vectors, which is that when you add two vectors together, when you add two vector quantities together, you draw arrows to represent the vectors and you place them tip to tail. To place, so please write this down if you didn't last time, or please make a big point of this, because this is the takeaway for velocity vectors and for all future vectors that we're going to do. The takeaway is that when you add two vectors of any kind, you place the two vectors tip to tail, meaning the tail of one touching the tip of the other. And then the third vector that could be drawn to complete the triangle, the third vector that begins from the very first tail and ends at the very last tip, so in this case, the red vector, right? We've taken two black vectors and we've added them together by placing them tip to tail. The red vector that is drawn from the original tail to the final tip, that red vector that completes the triangle represents our answer, our sum of the two vectors. In this case, our total displacement. When I say represents, I mean, like I said last time, I mean that the closer I draw these black vectors to scale, the more accurate that red vector is going to be. And if I only sort of roughly drew them approximately, then what that red vector is approximately telling me is that for my final answer, I might not know it exactly just looking at that picture, but I should expect that my final answer will be a vector. Well, first of all, my final answer will be a vector. If I'm adding two displacement vectors together, I'm going to get a vector, which means my final answer better have magnitude, size, and it better have direction. And in 2 dimensions now, direction is an angle and points of the compass. So the final answer I'm looking for, when I say how far what's the final displacement vector of all this, I'm looking for something that has a size and an angle, an acute angle with points of the compass. So this red arrow in this picture depicts what I'm expecting my answer to be, something of a length that is more than 5, more than 8, but probably less than 13, right? My final answer is going to be greater than 5 in magnitude, is going to be greater than 5, greater than 8, but less than 13. Where am I getting 13 from? 13 is 5 plus 8, right? I'm saying my final answer will be greater than 8 or 5, but it's not going to be 8 plus 5. Even though I'm adding the vector 8 plus the vector 5, since they're going in different directions, I'm going to get something that's not quite 13 units long, right? That's what that red line is indicating to me. And it's going to go in some direction that I think is going to be some kind of southeasternly direction. I don't think it's going to be exactly southeast, and I don't think it's going to be exactly 30 degrees southeast, and I don't think it's going to be exactly 60 degrees southeast. It's going to be some kind of angle southeast. And that's what I'm expecting my final answer to be. But now to get my final answer, and I'll try to speed this along because I know we did this, but I'm just summarizing. To get my final answer analytically, the method I did was I took each individual vector and I zoomed in on each individual vector, and I treated each individual vector as the hypotenuse of its own little right triangle. And then I used right triangle knowledge in order to break down that individual vector into a horizontal component and a vertical component, an east-west piece and a north-south piece, right? Because the whole principle we're doing here is that anything that happens in 2 dimensions is really two things that happened. Anything that's happening in 2 dimensions is really two sets of things, each one of which is happening in 1 dimension. So any 2-dimensional problem or phenomenon or displacement is really 2 1-dimensional displacements or phenomena or experiments, each of which is happening independently yet simultaneously with the other, right? So I'm saying that when you go 5 meters to the northeast, if you walk 5 meters at 30 degrees northeast, if you zoom in and look at that the blue circle around that vector, if you zoom in on 5 meters at 30 degrees to the northeast, what I'm saying is that in itself is an addition. That's a tip to tail sum of 2 smaller vectors, a vector that brought me somewhat, oh wait, hold on a second. 1 second, sir. Okay. 5 at 30 degrees to the northeast is really some amount east plus, so some arrow drawn to the east plus some arrow drawn to the north, some tail to a tip going east, and then from that tip, some tail to a tip going north. Northeast is really the sum of some amount north, or some amount east plus some amount north. And similarly, independently yet simultaneously, southeast is really some amount east plus some amount south, right? So we take each, so this is always true. Every vector you get, you first break up into its individual, its independent yet simultaneous components, line. Oh, sorry, okay. So we're trying to add two vectors together, but I'm saying by tip to tail method, but I'm saying actually in order to do that, you got to back up and zoom out and zoom in and see that each vector itself is already a sum of an x-axis piece and a y-axis piece. And why do we do that? Because all of the physics that we spent all this time maybe boring you to pieces doing up until this point, all the physics we've been developing is the physics of a number line. Our very first homework assignment was number line for a reason. We know at this point in depth how to analyze anything going back and forth in a line. And of course, you might well think, or you might well have been thinking, well, this is really getting boring. I mean, my God, like all of this work just to understand what's going on in a line, like really? Can we get on? But what we're saying is that's all we ever need to know. As long as we really know what's going on in a line, then anything that's going on in a plane is just stuff that's going on in a line at the same time as stuff that's going on inside a line. And then you might say, yeah, but isn't this line different from that line? We say, no, it's just a line. That's Galileo. Physics is physics is physics is physics. Physics is physics in every coordinate system. You see, so it's like philosophical and it's very mathematical. So the math is that we take, okay, so I know we already did this, I'm sorry. So, but we take each vector, we break it into its components. Then as you saw last time, we then use, so there's always right triangles. There's as many right triangles as there are vectors involved in the problem. Every vector is its own little right triangle. So then we divided the vectors into their x and y components. Okay, we did this already last Wednesday. Then we made an XY chart. We always do that. You make an XY chart to accumulate, to make a running tally of everything that's happening in the x-axis, while independently yet simultaneously, you're tallying up what's going on in the y-axis. So we said that to go like this and then like this is really to go like this and then this, while at the same time going like this and then this, right? So we just tallied up the x's and the y's. We took into account minus signs, like, right? And we got the minus signs by being careful in our triangle, by putting tips and tails in the direction that we should, right? So we're being very careful about tips and tails. Warning on the exam, no matter how much you think you know your math of right triangles, this is not just math. This is physics. We're worried about directions in space. So all these triangles are made from vectors that are being put together tip to tail. So for example, that vector right at the top of the page here, we're saying 5 itself is the tip to tail sum of 5 cosine theta, 30 degrees, plus 5 sine theta, right? Notice if I'm saying two vectors placed tip to tail, it means add the vectors, and the answer is whatever completes the triangle, then you might want to write this in your notes. Then conversely, any two vectors that are placed tip to tip or tail to tail are vectors that are being subtracted, right? Like notice, like in this thing right here, or if you go back to the original diagram, like we're saying black plus black equals red. We walk like this and walk like this. That is ultimately equivalent to having walked like this. But similarly, then red minus black equals black, right? The overall displacement minus one of the others equals the other of the others. Tip, tip, or tail, tail means subtraction, just like tip to tail means addition. And that is important, particularly for velocity vectors. Okay, so every time I say we're learning about vector addition right now, we're just as much learning about vector subtraction. Okay, so we did this yesterday. We broke up one individual vector, we broke up the other. we made a running list. We put the vectors together. I mean, we got our final totals. We made one big vector out of the totals, and that was on this last page. This was the last thing we did. We made one big final our totals were the 8.3 to the east plus negative 4.4. Why negative? Because to the, or what does the negative mean? It means to the south. So in the end of the day, we walked all the way east, 8.3, and we walked from that tip. We started a tail and we walked 4.4 south. And so our ultimate answer is the hypotenuse, the dotted diagonal line formed by those two total. So that's those two legs are our total X and our total Y. Put them together and we get our total. So we said at the end of the day, our final distance that we traveled was like 9.39 meters. And our final direction that we went in was like 27.9 degrees southeast, right? Because I did tangent of theta equals 4.4 over 8.3. And then in my calculator, I did inverse tangent or arctangent or tangent to the -1. In other words, I did tangent backwards to get the actual angle. And so in sum, this was the answer. This is the answer from yesterday. Notice. So the final answer was like 9.3. It's approximate because we did square roots and cosines and stuff. So we had to chop off digits. It's not approximate because it's a guess. It's not a guess, but we just had to chop off digits and round. So maybe if you took an exam, maybe you get 9.40 or 9.37 or so. That's fine. But we get like 9.39 meters at 27.9 degrees southeast. It's definitely south. It's definitely south of east. There's no negative sign in my angle. Because that would be ambiguous. It's an angle, it's an acute positive angle with points of the compass. Notice our answer, just like we predicted, is more than 5, it's more than 8, but it's less than 13. And it's a weird number that I could never have just guessed by just eyeballing this, right? I actually had to go through the work to get that number 9.39. Similarly, the angle is a southeastern angle like we predicted, and I think makes sense, but it's a bizarre number that we had to go through the work to get. It's not 30 degrees, it's not 60 degrees, it's not 90 degrees, it's 27.9 degrees. Okay, I'm hoping to end a little bit early today, maybe as I say, I think both the classes are at the same point now. I'm not going to hold you on necessarily too long, but first, before I want to make sure, I'm going to pause for a second. And I'm going to warn you too, and I say a little bit early, like I mean in about 5 minutes, we'll probably go, but well, I shouldn't even say that. Wait, I shouldn't even say that. That's going to make people, I'm not going to introduce any new material today. I'll say that. I'm not, there's no need. But one, just let's relax for a second, since we still have 20 minutes and I often am rushing at the end. Let's pause for a second and please look, now that I've gone over it twice, it is a big deal adding vectors by the component method. You might have done it before in high school, or you might have added vectors by other methods. That's fine, but I need you to know this method as well, believe me. And like, say this were on the exam and I gave you this problem, and this already came up in the other class in a different, there's a million ways to add vectors and stuff. But if on the exam, if you give me a whole way of adding these two vectors that has to do with like law of cosines or like something like that, that you get from Chegg or you get from a website, like even if it's correct, I got to tell you, if it's not the method that you did in this class, I'm going to be looking at it with a lot more scrutiny. I'm not saying that there aren't more than one ways to do this. And if you're really correct and you really get it and you really understand what you're doing, I'm not going to punish you. I'm not saying everybody always has to do things my way, but I am saying this is a class. And you're here to learn things that you didn't know before. So you are being tested on this. So just as a little warning, like if you suddenly at the last minute just try to do these problems just by whatever method is on the web, and you don't show any, and you make it very clear that you haven't been paying attention to anything we've done in class, and you just do something that you got from the web, you're going to be held to a high degree of scrutiny. Like, I'm going to make sure that you really understand what you got from the web. And I got to warn you now that I think the things that I'm teaching here are a lot clearer and easier to follow if you try to follow them than things that can just be copied from the web. So don't just copy things. Anyway, therefore, I want to pause for a second and say, number one, even if you've seen adding vectors before, or you think you know other ways, or something, something, something. Can everybody look at this right now and see? We still have like 20 minutes. So just see, do you have any questions about what I did right here to add these two vectors together to get a total resultant vector? Like, can you just pause for a second and look, see if you have any questions about this? I mean, it is you on the exam. Okay, can I see? Take your time, but I'm just looking in the direct chat. And you could put in, you don't have to, there's no shame, but do you think you understand what's going on? Can I see electronic hands if you think you understand what I've just presented here? Cool, I appreciate that. Okay, cool. I totally appreciate that. I'm not even gonna say the names, but I appreciate that. Now put your hands down. Actually, I'm gonna be really firm for a second, just because I just want everybody to do well. So put your hands down for a second. I totally believe you and I appreciate it. Now, just for my own curiosity, can you raise your, oh, thank you, Jada. That's cool. I get it. That's cool. Now you can put your hands or your hand, your that. Now, just be honest. Either way is fine, but raise your hand if what you're seeing now is somewhat, even slightly new to you. Like nobody. So raise your hand if this is all, no, but be honest for a second. So raise your hand if the way I just taught this, or the way I'm saying to add vectors, raise your hand if it's at all, if any aspect of it is at all new to you, not necessarily the answer, but just like the way of doing it. Just one person. Okay. Raise your hand if it's old, if all this you've seen before. Be honest. I'm not going to change the exam or something. I just want to know. Wait, no, wait, there's only two options. Either it's old or it's new. Raise your hand if this is old news to you, this adding vector stuff. Wait, okay, thank you, Kay. Oh, I like Kay's hands. Wait, Kay's the only person? Okay, wait, raise your hand if you hear me talking right now. That should be everybody. It's okay, now I'm seeing in the chat. Okay, thank you. Now people are, wait, let me see in the chat what you guys are saying. Wait, it's pretty much all new. Oh, okay. It's both and no, both old and new is honest. That's fair. I can understand that. Someone saying in direct chat it's pretty much all new. Okay. I'm just trying to get a sense. All right. But you guys do think you get, all right. I will say the reason I'm, okay. One thing, especially if it's sort of both old and new and you're not even sure where it's old. Oh, we did it. Oh yeah. And lab. Oh yes, there's lab. Good. That's very honest. Someone just put, we did it a little bit different in lab. So it's old, but this way is a little new. Okay. And by the way, good point. All right. And I'm not trying to hold you. I'm just trying to be as clear and as fair or whatever as possible. Number one, you're absolutely right. I almost forgot to mention, yes, this is all like lab 3 was meant to get this whole thing off the ground. What I'm trying to do here is a method. What lab 3 is trying to show, and we always try to do this in physics. I'm trying to show that if you were left up to your own devices and you didn't have rules or regulations or methods or formulas, and you just like had to gut your way through something, that what you would come up with would be very much like this. Like this is meant to show something that's kind of is a natural process. And that is what you did in lab 3. That's absolutely right. And then it might be explained one way or another. What I'm trying to do here is put in cement. I'm trying to put a script down to something that is somewhat natural if you had to come up with it on your own. And that's honestly what physics is meant to be in general, is a formalized script of what we all would actually come up with if we had enough time and nothing else to do and enough incentive. So if it like sort of resembles what you did in lab 3, but not exactly, that's actually kind of a perfect thing to say, because yes, this is meant to be the formalized takeaway script from what we funked around and experimented with in lab 3. I mean, that's a good point. I'm going to let you go I really am going to let you guys go. I'm not trying to overwhelm you, but I want to say with this method of adding vectors, it's going to be the same method we're going to use for 2 physics classes. Like we're going to use it for velocities, forces, everything. It gets harder and harder to see what's physically going on and what it means with all the other vectors. It's easiest to see with displacement vectors, but it takes practice. I'm going to warn you right now. It might sort of make sense when I'm explaining it or when your lab instructor explains it, but you see a lot more things when you actually practice it, like anything else in life. So I will just say, because I promised I would let you go early, that when I upload these notes today, notes are redundant from last time. It's sort of the same package of notes, but you'll see that I added a couple of pages, which I encourage you to look like. There are a couple, oh, someone just, sorry. There are a couple of pages, there are a couple of pages added where I show some options that are what you have to do when you, the bottom line is this: whenever you take two legs and make a final vector, like we did at the end with 8.3 and then 4.4, there's many ways to do that. When you're practicing, you'll see that there's many possible choices, and some choices are better than others. I just made the right choice, and it makes it seem like the only choice, but it isn't. So whenever you're drawing vectors, here's the tip, or the technique, just the trick to write down that I tried to include in these pages here. Whenever you're putting vectors tip to tail, when you're, especially components, when in doubt, or when you have a choice, always draw the horizontal one first. And then from the tip of the horizontal one, draw the tail of the vertical one. You'll see as we go why that's a good trick. It's not a law, but it always works. It's a good strategy. Always draw your horizontal one first, and then draw the vertical one's tail from the tip of your horizontal one. So whenever we're doing tip, and sometimes there is no horizontal and vertical, but whenever there is, draw the horizontal one first. And that's like my advice for now. Let me just edit. So this is the summary of it's due for your class. Sorry, the exam is right. So this is the last time I'm summarizing the exam fact here, so there's no ambiguity, but okay, as long as it's all clear what we said about this example and about the exam, you can still text me and email me questions, of course. We still have plenty of time before, but I want to be clear. Okay, now I'm late for being early. So I'm done. If you're good, like, have a great day and a good Halloween. And I'll see you. Bye. Happy Halloween. Awesome. Thank you. Thank you. Awesome. Thank you. Awesome. Thank you. Happy Halloween. Awesome. Oh, thank you. Thank you. Awesome. Awesome. And you're good at, okay, I'm stopping the recording.